Hello friends, welcome to my channel. In this video, I will cover ISRO 2017 paper. This is part 5. Question is, a rod of length L and area of cross section capital N and has a modulus of elasticity E and coefficient of thermal expansion alpha. One end of the rod is fixed and other end is free. If the temperature of the rod is increased by delta T, then it's free. One end is fixed, other end is free. So thermal strain is 0. Thermal stress is 0 and thermal strain it will develop. Thermal strain is one end is free, so sigma T thermal stress it's 0 and thermal strain it's alpha delta T. So from option, stress developed in the rod, so not possible, stress is 0. Strain developed, it's correct. Stress developed rod is 0 and strain developed in the rod is minus alpha delta T. This is also minus, so not possible. Stress developed in the rod is 0 and strain developed in the rod is alpha delta T. C is the answer. The entropy of a hot baked potato decreases as it cools. It's cooling, so entropy also decreasing. Above statement is correct. A is the answer. During January, at a location of Rohtang, winds at minus 6 degrees Celsius can be observed several meters below the ground. The temperature remains at 27 degrees Celsius. A scientist claimed to have devised a power cycle exploiting the situation that has a thermal efficiency of 10%, whether the claim is true or not. So ideal thermal efficiency we have to calculate, or thermal efficiency of ideal cycle, it's work done divided by heat supplied, or maximum temperature minus minimum temperature divided by heat supplied is maximum temperature. So maximum temperature here is 27 degree minus 6 divided by maximum temperature, it's 27 plus 273. You will get 33 divided by 300 into 100. So 11. Ideal cycle efficiency is 11%. That scientists claim efficiency is, this is scientist efficiency 10%. This is less than ideal efficiency, so cycle is possible. A is the answer. Side relief angle in a cutting tool signature is given. Side relief angle you have to calculate. So here for side view, it's side view, then it's front view is this one, front view, then top view. From side view you will get, this is flank and base. This angle is back rack angle and this angle is end clearance angle. This is back rack angle, this is end clearance angle, this angle, end clearance angle. And from top view you will get this angle and this angle. This is end cutting edge angle, end cutting edge angle. This is side cutting edge angle, side cutting edge angle. This is face of the tool, cutting tool. This is shank. And in front view you will get these two angles, side clearance and side rack. This is side rack angle then this angle is side clearance angle. Side clearance angle. So in this question, first you will get back rake angle. This one 10 is back rake angle. Then side rake angle. Side rake angle is 20. Then end clearance and side clearance. End clearance is 7. Side clearance is 6. In this question, they are side relief angle or side clearance angle. So this is 6. C is the answer. Then you will get end cutting edge angle. This is 8. And side cutting edge angle. This is 5. And 2 is nose radius. One more angle is important. This is leap angle. This is leap angle. This is also important. So they may ask other angles also. So other angles also you have to remember. 10 is back rake angle. 20 is side rake angle. 7 is your end clearance angle. 6 is side clearance angle. Then 8 is end cutting edge angle. 15 is side cutting edge angle. 2 is nose radius. The missing distance between A and B in the pin figure shown below is how much? This type of question in GATE also they already asked this type of question. So this is very, very important. So from here to here we will consider this one. 45 plus maximum value of this one. 45 plus 0.5 equal to minimum value of this one and this one plus this one maximum value. So 45 plus 0.5 equal to maximum value of minimum value of 30 minus 0.2 plus minimum of 13.2 minus 0.5 plus AB. This is AB, this distance. So AB maximum. So from here you will get AB maximum value. AB maximum is 45.5 minus 29.8 minus 13.2 minus 0.5, it's 12.7. You will get 3.0. Then for minimum value of AB, it's 45 minus 0.5. Maximum of this total value, or minimum of this total value is this one maximum plus this one maximum and AB minimum. So 30 plus 0.2 plus 13.2 plus 0.5 plus AB minimum. So from here you will get AB minimum value. AB minimum is, you will get 44.5 minus 30.2 minus 13.7. You will get 0.6 value. So AB maximum equal to, here we got 3.0 and AB minimum equal to 0.6. So from options we have to check the missing distance between A and B. So if you check from the options, A and B value, C is our correct answer. 1.8 for maximum value, 1.8 plus 1.2 you will get 3. This is satisfying. Minimum value 1.2 minus 1.8 minus 1.2 you will get 0.6 value. This is also satisfying. So C is our answer. In an ideal gas turbine cycle with intercooling, reheating and regeneration, as the number of compression and expansion states are increased, which of the following statements are correct? So Brayton cycle reduces to Ericsson cycle? No. Brayton cycle reduces to Stirling cycle. This is correct. Cycle efficiency becomes equal to Carnot cycle efficiency because this is intercooling and reheating regeneration. So cycle efficiency becomes equal to Carnot cycle efficiency. So double I and triple I. D is the answer. The method of development of a right rectangular prism is parallel line method, radial line method, no. Triangulation method, this is also not possible. Approximation method, no. Parallel line method, this is the answer. Below the ductile to brittle transition temperature, weld joints show high ductility, no. High toughness, no. Low toughness, they will show. C is the answer. Question is, what is the Prandtl number for a gas at 27 degrees Celsius and 1 into 10 to the power 5 Pascal with kinematic viscosity equal to 1.8 into 10 to the power minus 5 meter square per second. Specific heat capacity at constant pressure equal to 700 joule per kg Kelvin and thermal conductivity of 0.02 watt per meter Kelvin. Take gas constant equal to 300 joule per kg Kelvin. So data given are kinematic viscosity, it's 1.8 into 10 to the power minus 5 meter square per second. Cp is 700 joule per kg Kelvin and temperature T is 27 degrees Celsius or 300 Kelvin. K value thermal conductivity, it's 0.02 watt per meter Kelvin. Gas constant R is 300 joule per kg Kelvin. So mu value first we have to calculate. Mu equal to, we know kinematic viscosity, it's mu by rho. So density value first we have to calculate. Density is PV equal to MRT. From here rho equal to P by RT. P is 1 into 10 to the power 5. So 10 to the power 5 divided by R is 300 into temperature is 300. 0000 10 you will get 10 by 9. So from here mu equal to density into kinematic viscosity. Density is 10 by 9 into kinematic viscosity 1.8 into 10 to the power 5, or you can divide 10 to the power 5. Here you will get 10 to the power 4. So you can write it as 18 by 9 divided by 10, 2 by 10 to the power 5. This is mu value. So we have to calculate Prandtl number. Prandtl number PR is mu Cp by K. So mu value we got 2 by 10 to the power 5 into Cp already given in this question. It's 700 divided by K value is 0.02 or 2 by 100. 2 cancel. 10, 7 by 10 you will get 0.7. This is the answer. So from option C is the answer. In continuous casting process, the mold is generally made of cast iron, no. Bronze also no. Copper. Copper is the answer. At re-entry module flies with Mach number 10 at an ambient temperature of minus 27 degrees Celsius with Cp equal to 840 joule per kg Kelvin. Gas constant R equal to 140 joule per kg Kelvin. What is the stagnation temperature at the tip of the nose of the re-entry module. So we know our formula, TO by T stag, it's equal to 1 plus gamma minus 1 by 2 into m square. So TO given in this question, TO is ambient temperature minus 27 degrees Celsius, m is 10, Cp not required, or for gamma value Cp and R required. Sorry, here this formula is T stagnation divided by TO. So gamma first we have to calculate, Cp minus Cv equal to R, or divide Cp, Cv equal to Cp minus R, Cp is 840 minus R is, so you will get 700 Cv. We know Cp by Cv is gamma, so Cp is 840 divided by 700. So you will get 12 by 10. It's 1.2. So gamma is 1.2. Then T stagnation equal to TO into 1 plus gamma minus 1 into by 2 divided into m square. Gamma minus 1 by 2 into m square. This is the formula. This formula is very, very important for ISRO exams. Then put the value. TO is static temperature. It's minus 27 degrees Celsius. So you will get 246 Kelvin. So 1 plus gamma is 1.2 minus 1 divided by 2. M value is given. It's 10 square. So you will get 246 into 1 plus 0.2 by 2 into 100. So you can write 2 by 10. 2 cancel. 10 plus 1, it's 11. 246 into 11, you will get 2706 Kelvin. So if you write in Celsius, it's 2430 degrees Celsius. 2430 degrees Celsius. This is our answer. From option. So from option approximately C is the answer. Which one of the following steels contain least percentage of carbon? Least percentage of carbon, D is the answer, IF steel. The Lewis number, which is a measure of relative thermal and concentration boundary layer thickness, is defined as RE is Reynolds number, PR is Prandtl number, and SC is Schmidt number. So we know Lewis number LE is Schmidt number divided by Prandtl number. It's kinematic viscosity divided by D. Prandtl number is kinematic viscosity divided by alpha. Thermal diffusivity by diffusion coefficient. Finally, we will get thermal diffusivity divided by diffusion coefficient D. Alpha is thermal diffusivity, alpha equal to K by rho Cp. So it's thermal diffusivity divided by diffusion coefficient. This is Lewis number. Then one more thing is important here. Reynolds number into Prandtl number. This is Prandtl number. This is also important. Reynolds number into Prandtl number. This is P and this is LE. Lewis number. So from option B is the answer. And Prandtl number, we know it's momentum diffusivity by thermal diffusivity. This one. And Schmidt number, this is kinematic viscosity divided by diffusion coefficient D. Same question was asked in IS 2016. The figure shows an aluminum rod of 25 mm square cross-sectional area. It's loaded at 4 points KLMN. Assume E equal to 67 GPa gigapascal. For aluminum, the total change in the length of the rod due to loading as shown in the is close to how much? So delta value we have to calculate delta length. So 3 sections are there, section 1, section 2 and section 3. L1 is 500, L2 is, this is L3, L3 is 400. So L2 equal to 1700 minus 500 minus 400, you will get 800. So individually we will calculate. For section 1, del L, this is KLMN, but del L KL section is PL by AE. Formula we have to use. P is 100 Newton, this is tensile, L is 500 divided by area is 25 into E is 67 gigapascal. So you keep as it is AE. Then for second section del L, this is ALM, PL by AE. P is 100 Newton minus 250 Newton, you will get minus 150. Minus 150 into length is 800 divided by AE. Like this, del L of third section AMN equal to, you will get 100 minus 250 plus 200. If you check left side, it's 100, tensile, compressive 250, this is tensile. So compressive load you will get, or sorry, the tensile load you will get 300 minus 250, tensile load 50 Newton you will get, 50 into length is 400 divided by AE. So total del L is, total change in length is del L of section 1 KL plus second LM plus del L MN. So take AE common, 100 into 500 minus 150 into 800 plus 50 into length is 400. So 1 by AE, here you will get 00 minus 15 into 8, it's 120, then 000 plus 20, then 000. Then put the value of AE 50,000 divided by A is 25, area is 25, E value is 67 into 10 to the power 3, 10 to the power 3, 3 cancel, it's 2 minus 2 by 67. So multiply 1000 for micron and 67 you make 60, 0 cancel, 2 by 6 it's 3, 100 by 3 it's minus 33 micron. So from option nearly minus 30 micron, C is the answer. The basis of slip line field theory in metal cutting It's Lee and Sapper theory. So from option B is the answer. This is the end of part 5. Thank you friends. Thank you for watching my video. Thank you.